in this example, we're given the graph of f of x, and let's use the three criteria to determine if f of x is continuous at 1, 2, 3, 4, and 5. Recall that the three criteria are that f of a has to exist, that the limit as x goes to a of f of x exists, and that the limit as x goes to a of f of x is equal to the value of the function at a. So first we'll ask ourselves for our function at 1, does f of a exist? And here the answer would be yes. When you plug in 1 into your function, you get the number 3. So yes, and f of 1 would be equal to the number 3. 2. Does the limit as x goes to a exist? And indeed it does. As your x's get close to 1, either from the left side or the right hand side, the values of my function will be getting close to the number 3. So yes, and the limit as x goes to a of f of x is the number 3. In this case, the limit of the function and the value of the function are both the same, so the third criteria is met, that the limit as x goes to a of f of x would be equal to f of a. And again, for the limit, we got 3 from number 2, and for the value of the function, we got 3 from number 1. So yes, we do have that equality holding, and since all three criteria are met, our function is continuous at x equal to 1. We can repeat this process and see if our function is continuous at 2. Let me copy this function down, and let's again ask ourselves the question whether or not our function is continuous at 2. So again, we have three criteria to meet. First of all is the value of my function existing. Does f of 2 exist? And in this case, when we plug in 2, we see that we have nothing. Our function is not defined at 2. So here, no, f of 2 does not exist. And we stop immediately. So since f of 2 does not exist, then there's no point in checking the second and third criteria. Immediately you can say that your function is not continuous at x equal to 2. Continuing this process, is f of x continuous at x equal to 3? Again, we will ask ourselves whether it satisfies the three criteria. 1, does f of 3 exist? Indeed it does. When you plug in 3 into your function, you will get 2. Again, this is the value in our function that we're referencing, and in this case, your f of 3 would be 2. 2. Does the limit as x goes to a, in this case a was 3, exist? So as we come in from the left and the right towards 3 for our x's, the y values of our function will head to the same y value from the left or the right to the y value of 1. So again, the limit as x goes to 3 of our function would be equal to 1. And in the third criteria, we'll be asking, does the limit as x goes to 3 of our function equal to the value of the function at 3? And clearly it doesn't, because the value of the function is 2, but the limit is 1. So in this case, those two values are not equal to each other. So the third criteria fails, in which case you can say that the function is discontinuous at x equal to 3. Now let's consider if our function is continuous at the number 4. Again, we'll analyze our three criteria, asking ourselves, first of all, does f of 4 exist? And indeed it does. When we plug in 4 into the function, we'll get the value 4. Two, does the limit exist? Now here, if we have our x's going towards 4 from the left-hand side, the value of our function heads towards the number 2. So the limit as x goes to 4 from the left-hand side, the value of our functions will be heading towards the number 2. And as our x's head towards 4 from the right-hand side, the value of our function will be headed towards 4. In this case, the limit from the left is different from the limit from the right. So in this case, the limit as x equals to 4 does not exist because these two values do not concur. They are not the same. So no, it does not exist. And from here we stop and say that our function is not continuous at 4. Now we ask ourselves whether f of x is continuous at x equal to 5. And in this case, I'll just do this one quickly. It's clear that it is. The value of my function at 5 is going to be 3. And whether you're coming in from the left-hand side or the right-hand side towards the number 5, the y values of your function will be headed towards the number 3 as well. So in this case, the value of the function is 3, and the limit as x goes to 5 is equal to 3. So in this case, if we have all three criteria met, and f of x will be continuous at x equal to 5.